What's up there, CW fans? We're going to be, actually, I should probably back up. There might be some folks watching this that are not CW fans and just want to learn a little bit more about serial ports, COM ports, something called RTS, DTR, and maybe you want to know about this thing called a CAT interface. But today we're going to talk about serial ports, a little bit of history behind some of what we've been talking about in ham radio for like a million years, and it seems like ham radio is one of those things where we just can't get rid of. We want that backwards compatibility so much, and we still talk about COM ports and interfaces and stuff like that, even with some of the direct USB interfacing to some of the modern rigs right now. We still talk about RTS, CTS, COM ports, and stuff like that. So I think this might be a good primer for kind of where we came from, why some of the things are called the things they are, and really kind of like move our way up into how things are today. So I guess to start off, let's do a little bit of history. Back when I started doing ham radio, it was in the early 90s, like 1991, 92. I wound up testing in 92, and then I got my license in 93. I think January it actually came, so I was pretty excited. My first computer was what you see on the screen here, was an IBM PS2 Model 30, and the only real way to interface to computers back then was via a serial port. And I've got a little image of one here on the screen where you can kind of see that there's a mouse that is connecting to the serial port. So even like mice back then, you'd have a serial port mouse, and that's how you would interface to a computer. And quite frankly, when I did a bunch of work for, when I was in high school and in college, I did work on larger computers like mainframes, VAXs, and stuff like that. And a lot of the interfacing to computers happened through serial communications. As a matter of fact, some of the first networking that I was exposed to had nothing to do with Ethernet. As a matter of fact, I also did token ring, 10 base 2 coax, but some of the first networking was serial cables. So we would be daisy chaining serial cables between computers to be able to get them to talk to each other. So super old stuff, right? We're talking 80s technology. Well, probably technology earlier than that, but we were using that in the 80s, and we eventually moved and migrated off of that. However, ham radio, we still kind of like harken back to the old stuff because we need so much massive backwards technology or backwards compatibility, or we just can't kind of lose some of this history. So this is what it kind of looks like, and that's kind of how computers used to really connect to each other. And I've had serial mice, tons of serial mice over the years, and actually technically I still do, right? They're all USB now, right? Universal serial bus USB. So all my mice are still serial mice. There was a period of time where IBM developed a standard called the PS2 mouse, where it would be like a round connector. So that's a little bit outside of the scope of what we're going to talk about today, though. But first, let's talk a little bit about serial port architecture. So you saw on that computer there was a 9-pin connector on the back. And each one of those pins has a certain duty. And I'm going to get my highlighter out and highlight a couple of these pins here. So when you are talking computer to computer with the serial port architecture, you only really need to connect the ground, the transmit, and the receive pins together, especially like today. To be able to enable communications, there's a transmit pin, there's a receive pin, and then on the other end, you would swap the transmit and receive so that you would actually have two-way communications. So that's all you would really need for bits to be communicating between two machines, or maybe a communications piece of equipment, and what they would call a terminal or a computer. Now, back in the day when computers were not super fast, there was a lot of, it just wasn't fast at all. So what really needed to happen was they introduced like kind of a flow control protocol, and they started to utilize something called DTR, DSR, RTS, and CTS. So the DTR and DSR were two pins that would go live and communicate with each other when there was equipment connected on each end of the cable. So you would know that something was connected, we could actually do some communication, stuff like that. There was an RTS and a CTS line that was managed by each side of the serial cable, so that the computer would know, because it would be crunching data, and then it wouldn't be able to like ingest information from the serial port until it was done computing. And I know it's kind of hard to understand, but when computing was super slow back in the day, you had some delays and you had to wait for stuff. So each side of the serial interface, and I'm being very generic here. Maybe some of the folks in comments might be like, hey, that's not exactly how it works, and you'd probably be right, but each end of the serial cable would, or each terminal, like whether it be the terminal or the computer on the other side, would turn on the CTS or the RTS line so that the other side would know that it's ready to accept data. I'm too busy crunching data right now. I can't accept anything right now. And then it would say, okay, it would light up the clear to send signal, and the other piece of equipment would send the data through the TXD and the RXD lines. So that's kind of how that worked. But as time went on, the CTS and RTS lines really started to become unnecessary because the speed of computers were so fast, and quite frankly, the serial port architecture was so slow compared to the speed of computers that it really wasn't necessary. You can just like pipe data right down the line and it would be acceptable, especially today, because gosh, I think the maximum speed of a serial connection is was it 115,000 bytes or 115K or something like that. I don't know, it might be a little bit off on that, but it's really low in terms of what bus architecture is today on computers. So that's kind of how that works. So all of a sudden we have this RTS and CTS line that each computer on each side can turn it on or turn it off depending on whether they're ready for data or not ready for data. You might even kind of see where I'm going with this. So in order to connect rigs or my trusty Yaesu 1000 MP to a computer, I needed to do it via a serial cable. And I think I bought my first 1000 MP in 1999, I believe. And then I wound up getting a 1000 MP Mark V in, gosh, 06 maybe? Something like that. And in order to connect my Yaesu, or quite frankly any other computer, like I had a Kenwood TS440 SAT, they would have a serial interface, and I've got a couple of plugs here to show you what that looks like. You'd connect the radio via serial cable to the serial interface. Well, nowadays there really aren't computers that you can get a serial interface, like they call this a DB9 connector here, because there's 9 pins and it's in the shape of a D essentially. So I wound up, this is actually one of the boards that I had in my computer. I wound up connecting this in here so that it gave me 4 serial ports. And I don't know if you can kind of see, like zoomed in, I've got some magic marker on one of them to actually show, because I couldn't tell which one was, it was like a COM 8, COM 9, COM 10, and COM 11 is how it appeared on my computer. So I'd be able to interface. I would just connect easily my serial plug, which looked like this, from my Yaesu FT1000 to my board right here. So I probably just kind of like plug it right in there, and I would be able to configure things like N1MM, or back in the olden days there were software packages called CT or NA for contesting. And my big time favorite by N6TR was TR log, which allowed serial port interfacing. So you go in there, configure it, say, hey, you know, I have a Yaesu FT1000MP, it's on COM port 7. Magic would happen. You'd have your serial cable connected up, and it would be great. Now, the biggest problem is I would be able to get a readout of what my frequency is. I'd be able to, like, you know, have the exact frequency that I was on in the log. I'd be able to see if I was on upper sideband, lower sideband, CW. There is a thing called CAT, which is really technically a rule set of, you know, when communications happen between a computer and a radio, the radio is going to send certain commands to the computer that'll say, hey, you know, this is what frequency I'm on, this is what band I'm on, this is what, actually it's redundant, what frequency I'm on, what mode I'm on, maybe some other things like, you know, what is the RIT setting, or, you know, maybe actually key in the radio, there's a key in the radio command, things like that. So this thing called CAT, I think it was pioneered by Yaesu. It's called Computer Aided Transceiver, and the commands that go along and through the serial cable are mutually understandable by, you know, the radio and the computer, especially, you know, the logging programs, stuff like that. So, but that's all great and everything. The biggest thing that was a void was, well, how do I key the radio? I want to be able to key the radio, and being able to do that through CAT wasn't available. So you could do a push to talk command, I believe, through the CAT catalog of commands through the serial cable, but there was no, like, let's key some CW through the serial cable. So what you had to do was do something like this. This is actually a cable that I had from, I believe this was maybe my Kenwood TS440, because it's got one of these round connectors on it. Here, let's see here. This guy right there. That was how I took this. This went to my computer. This was the DB9 connector, the serial connector. So that would plug into my computer. Let's say it's COM9, and through this cable, it would come out and be this. I think this was like a 6-pin DIN connector, I think they call it, or something. And this would connect into my Kenwood, and I would have to make sure that, you know, pins, I think it was pin 5 was ground, and then pin 2 and 3, which is the RX and the TX pins, would coordinate and be appropriately assigned to this DIN side here. Now you also see that, hey, there is a 1/4 inch phono plug here, which is something that you could use to key the radio. Well, somebody thought back in the day, hey, you know, we're not using those RTS and DTR pins anymore. You know, the RTS, DTR, CTS, and DSR, those are like 4 pins that aren't being used anymore. So, hey, let's turn those pins on and off in sequence, and let's take the CW that we would like to send to the rig and turn on and off the RTS or the DTR pin in sequence with, you know, with Morse code. So somebody thought of that and they're like, hey, that's a great idea. So basically, if you look at this mess, you'll see like a little bit in the background how I kind of soldered stuff together. I'll show you a little bit of a zoomed in picture of that. But I've got pins 5, which is ground, pins 2 and 3 of the serial cable connected in and through to that Kenwood DIN connector. Okay, cool. So we've got radio communications, but I also have and let's go back to this here. I like to use the RTS pin. So that's pin 7 on the male side of the connector. So we'll use RTS. So pin 7 is going to essentially be connected to my CW plug. So pin 7 will be connected to this. And then also pin 5 needs to be connected to it because pin 5 is ground. So we need to have a ground for a complete circuit. So that's how that mess happened up here. The cool thing is, and maybe it's not a cool thing, is that's what that mess looked like. And you're probably thinking, wow, there's some resistors in there. It looks like a couple of transistors. What in the world's going on there? Well, in a perfect world, you could say, sure, let's connect these pins directly, and let's make sure everything, the communications is going to happen. Connecting pins 2 and 3 to RX and TX side of that DIN connector should be no big deal. But somebody say, hey, there might be some weird voltage fluctuations. I don't trust ham radios. Maybe I have like a home brew device or something. Let's put a transistor in the middle of there. So if something weird happens, the transistor will get smoked instead of my serial board on my computer, which is a lot more expensive. So somebody came up with this RS-232 keying schematic. So what you see here is we've got this, we've got the RTS pin. So this is the serial cable, and out of that I have this RTS pin, right? And that's going to connect to just a low value resistor, which is going to at least provide bias to the base of this transistor and be able to take the key line of the transistor or the transceiver and ground it, right? So when you add voltage to this, it's going to create a pathway in this transistor to then take the key line to ground. So that's going to kind of create an element of protection when you're connecting an RS-232 cable to a transceiver and vice versa. So if the transceiver has like some kind of a weird transient voltage, or something gets connected wrong, it's going to blow up this this transistor and maybe resistor or something, and hopefully and probably save the serial port on the computer. It's supposed to create a little bit of isolation also. I don't know if that's 100% true, but they've always said that. So that's kind of how we got to where we are. So we've got this serial cable. We're using this RTS line, or maybe even a DTR line, whatever you want. It doesn't matter. And you'll see in some of these logging programs, you can select whatever one you want. And we're keying the transceiver. I will tell you straight out that I have made cables without this, and everything's worked fine. I haven't blown anything up. So I just connect the pin 7 of the RS-232 cable right to the key line of the transceiver, and it's been fine. Of course, that would be you'd have to look at how the transceiver is keyed, if it's got positive voltage keying or negative voltage keying or ground-based keying. You might need this schematic because of that. But that's a little bit beyond the scope of what we're talking about today. So if you need to actually figure out how your transceiver is keying, that's also going to be a key. So, but yeah, I think getting into that is probably a whole separate video in itself. So the cool thing is when you plug in your COM port, it's going to show up in your device manager. So I've got that COM board that you saw in the previous slide, that once I plug that in, it turns out, I've got a single COM board in my computer right now, and it just so happens to show up as, it just so happens to show up as COM1. So that's cool. So I know that it's COM1 in my computer. Now, when I go to something like N1MM, I could select COM1 here. I want to make this a CW interface, and then I will hit the set button, and then this screen will come up. And this is where you can say, all right, well, I'm using pin 7 of my serial cable, and I want that to be the one that I'm going to send CW on. So N1MM has the ability to generate CW, and we've got macros, and there's like massive videos on N1MM and how that works. But this is where I set RTS pin 7 to be my CW pin, which is pretty cool. So now N1MM knows that on COM1 I have a cable connected to it, and I'm going to use the RTS pin to turn it on and off in sequence to make CW. Beautiful. So that's awesome, right? So now we've got a PC interface. So I've got a serial cable connected. Now I've got a second COM port, which, communications port, serial port, used interchangeably. So I have a second port that I'm just using one pin on in the ground, right? So I need pin 5 and 7. And I'm using that to key my radio, right? So that's pretty cool. All is good with the world. But what's going on today? We don't have any of that mess. Unless you're using an old computer, old technology like something that actually has a serial cable connection, like a DB9 or even like a DIN port, or some of the old style computers, you still need to do that old style interface and communications. But we've got USB now. If you have like an ICOM 7610, 7300, Yaesu FT101M, FTDX 101s, right? Those guys, or the Kenwood, was it the newest one, the 990 or something? And even the Elecraft K3, K3S, it's got the RS-232 board in there. The old ones, I think you can get an old one with a DB9 on the back of it, but the one I have right here is a serial cable. So it looks like this on the radio side, and then you plug this in to the computer side. That's all you need. So we are making progress. We have one cable solution without the rat's nest of craziness. So connect computer, connect the transceiver, and we are golden. However, we still harken back to like how we key the radio, and we use these terms like, hey, you know what, let's use RTS or DTR to key the radio. So we still have to do some of this stuff. So it's kind of arbitrary what we use for either RTS or DTR, because now that we have a serial cable, it's all programmatic. So we can say, all right, I want to use RTS to key the radio. Now on the radio, there's going to be something in the menu system, and I've got another video on this, for example, how to do this. I think I did videos on the K3S, the FT101MP, and also the ICOM, I think the 7300 and 7600. So you go onto the radio and you go into the configuration and say, hey, I'd like to key the radio, and I'd like to key it via the RTS port or the DTR port. So once you get the radio configured, and then you get N1MM configured to match, that's all you need to do. You don't need to worry about pins, because there are none on the USB cable, right? Let's see. There's none. You just plug it in, which is cool. So that's kind of like why we still talk about RTS and DTR today, because we still have that callback to the old days where we actually used pins, where you can kind of see there's pin 4 right there, or pin 7 on a serial cable to actually key the radio. Now we don't really need to do that anymore. However, we utilize those methodologies to be able to interface with the radio and the software, and to be able to have like some commonality to talk to each other. So that's kind of how that works, and that's how that went. So a little bit of history, and probably, and hopefully this helps clear up, like, why do I need to know what this is pin 7? Because in N1MM it still shows that, right? We got pin 4, pin 7. I don't even know what they're talking about, right? So it doesn't really matter. It's just they're kind of like leaving that door open to, you know, old school rigs and stuff like that that doesn't have like the new modern serial interfaces. So that's how that works. If you have any questions, certainly throw them in the comments. I've been doing serial port type of programming and interfacing for many years. I'm certainly not a master, but you know, there's like a lot of cool things you can do. Like I put together something called an FTDI 232 interface that will key my flex radio via foot switch. I'm kind of like doing some other things with old school serial communication. So it's kind of fun to still kind of mess with that technology, but the fact that these newer rigs and newer radios have just straight one cable USB capabilities is awesome. And when you do plug in that USB cable between your rig and your computer, you will be able to go into Device Manager here, and you'll be able to see those ports magically show up. I think, yeah, I don't even know if I don't have my radio plugged in right now to show you, but if I were to, you know, turn on my FTDX 101MP, all of a sudden there would be 2 additional COM ports, so 2 of them, that would magically appear, and one of them being an enhanced port, which would facilitate the communications to the radio, and then the other one would be a standard port, which you could use the classic pins like RTS and DTR, like the quasi pins, because they're actually not pins. You can use those communications for that COM port to be able to key the rig. So cool that we've got nice new technology, and it's kind of nostalgic that we're still like talking backwards and about COM ports and serial ports. So I hope this helps everybody, and if you're looking to do anything from a rig keying interface, maybe this kind of helps you. If you need any help with any of that stuff, keying old school rigs, let me know. I'll be more than happy to help or do a video on it. So thanks everybody, and CW on, my friends.